These last four examples may involve more than one step. In the first one, in order to get x alone, I need to get rid of a 6/11. So I'm actually going to do my multiplication and division at the same time. If I multiply by the reciprocal of 6/11, which is 11/6, the 11s will cancel out, the 6's will cancel out, and I'll have just an x left on the left side. But if I do that on this side, I need to do the same thing on the other side. Multiply by 11/6. So in order to do that, I put a 1 under the 12, and then I look for ways to reduce. 6 will go into 6 once and into 12 twice. So my final answer is 2 times 11 over 1. And since I don't need the 1, x is simply equal to 22. When I check this answer, I'm going to take 6/11, multiply it by 22/1 to see if it equals 12. So once again, I can do some reducing, canceling out the 11 and the 22 and making them into a 1 and a 2, and then multiplying 6 times 2, which gives me 12. In this problem, I need to get rid of a -1 and also get rid of the 6. So if you think back to the order that we do our steps in, we want to remove all the addition and subtraction before we try to remove things that are being multiplied or divided. So my first step with this problem is to add 1 to both sides. That will leave me with just a 6u on the left and 18 on the right. Now I'm going to divide both sides by 6 so that I get a final answer of u equals 3. To check my answer, I'll put the 3 in place of the u and use order of operations to see if this expression ends up equaling 17. So multiplication goes first, giving me 18 minus 1, and 18 minus 1 is 17. Two more examples. I'll isolate the variable here by getting rid of the -5 first, or the +5, I'm sorry, by subtracting 5 from each side of the equation. That will leave me with a -8/3 x equaling 36. Now to get rid of my -8/3, I need to multiply by the reciprocal. Remember, I don't want that negative sign to be left lying around either, so I'm actually going to multiply by a -3/8 on both sides of the equation, because the 3's will cancel out, the 8's will cancel out, and the negatives will cancel out. So really, I truly have only my x left on the left side. Doing my division on the right side, I can reduce 36 and 8 by a factor of 4. So 36 becomes 9, 8 becomes 2, and then I multiply 9 times 3 to get 27 over 2. Then since my 36 was positive and my 3/8 was negative, my final answer is going to be an x equals a -27/2. I still need to check this answer by taking -8/3, multiplying it by -27/2, then adding 5 to it to make sure that that number equals 41. I'm going to reduce before I do my multiplying. Then multiply a -4 times a -9 gives me a +36, which when I add 5 does come out to 41. In our last example, we're going to isolate the variable by clearing away some decimals. So our goal is to get b here by itself. right now it's got a minus 9 and 27 hundredths being subtracted from it, and a 4 and 5 tenths being multiplied. So I'll start by adding 9 and 27 hundredths to both sides. That will leave me with 4.5b on the right. When I add the 9 and 27 hundredths to the left side, I end up with 32 and 4 tenths is what's equal to 4.5b. Then I'm going to divide both sides by 4.5 in order to get b alone. Now I can't do this division in my head, so I'm going to come over to the side here and set up a long division problem. This hopefully you'll remember from our review at the beginning of class. I need to clear the decimal, then bring it up, and 45 will fit into 324 7 times, which when multiplied gives me 315. I'm going to subtract that and get 9. Since I have a remainder, I need to add a 0 and bring it down. Then 45 fits into 90 2 times. So my final answer is that b is equal to 7 and 2 tenths. When I substitute this answer in to evaluate, I get 4.5 times 7.2 minus 9 and 27 hundredths. Now 4.5 times 7.2 will equal 23 and 13 hundredths. And when I subtract, oh, nope, sorry, will equal 32. Looked at the wrong place on my notes. 32 and 40 hundredths. And when I subtract 9 and 27 hundredths from 32 and 4 hundredths, I'll get back to 23 and 13 hundredths, which was the answer I was looking for.